we're finally going to look at some segment and angle proofs. This is the first day of some examples of proofs. So some things to remember before we start these. The first thing is you always write down the given. Okay, and then you look for the picture given properties. You look at the picture, see if you can write anything down that comes from the picture. Then most likely you're going to use substitution or the transitive property. And then you look for other properties like addition, multiplication, any definitions. And then look at the line or lines above to help you to see what properties you can write down. Now I have a list of the properties, so you can go back and look at those to know what you can use. Okay, now this first one, if you notice, I give you the first column. I give you the statements. All you'll be responsible for is writing down the reasons. So all we have to do is look back at the given, look at the picture, see what we're doing here, and then write down our reasons, okay? So first of all, I give you that B is the midpoint of line segment AC, and C is the midpoint of line segment BD. And I've written that down in the first row, so I'm going to say that is our given, okay? Now, what this does for a midpoint is let's actually draw this on the picture, okay? B is the midpoint of AC. That means that AB and BC are congruent, which I see right here. And let's mark this, C is the midpoint of BD, so that means BC and CD are congruent, which is also written right here. So, and I use the midpoint to prove this, so, or write this down. So this is our definition of midpoint. I always look at my given first, okay? And then next it says AB is congruent to CD. So what I'm going to do is I'm going to look at this line above, okay, this line above, and I'm going to see if I did anything to get AB is congruent to CD. And I see right above it that AB is congruent to BC and BC is congruent to CD. And I can use my transitive property to cancel out the BCs and be left over with AB is congruent to CD. So to get that statement, that is the transitive property of congruency. All right, next we have AB is equal to CD. Well, if we look at a line right above it, I notice that the congruency and equality sign is changed, but AB and CD are the same. And when we change from congruency to equality, that's our definition of segment congruence. Okay, so that's our first proof, and that's all you're doing. You're just looking for the properties, the reasons of why I wrote those statements down. Okay, let's do another one. This next one, I give you that NQ bisects angle MNP, and that ray NP bisects angle ONQ. Well, obviously, our first reason is that it's given. Let's draw on our picture what this means. If ray NQ bisects angle MNP, right here, oops, then that means angle 3 is congruent to angle 2. Let's rewrite that given. Well, I see that written right here, okay? And then our next one, that ray NP bisects O and Q. Well, that means angle 1 is congruent to angle 2, which is right here. So I used my definition of angle bisector. All right, next up, angle 3 is congruent to angle 1. Well, I'm going to look at my line above because we've already done the given, okay? So I'm going to look at my line above, and I'm going to see if I can do anything above it. Well, I notice that angle 2 and angle 2 can be canceled out using our transitive, leaving us with angle 3 is congruent to angle 1. So that's our transitive property of congruence, okay? And then the next statement says a measure of angle 3 is equal to the measure of angle 1. Well, if I look at the line above, the 3 and the 1 are the same, but what's changed is congruency to equality. And when we change from congruency to equality, that's our definition of angle congruence. All right, and then we have the measure of angle 1 is equal to the measure of angle 3. Well, let's look at the line above. If we notice, we have the measure of angle 3 is equal to the measure of angle 1. So what we've done is we flipped it. We've just flipped this statement. So when we flip a statement, that's our symmetric. So this is our symmetric property of equality because we have an equal sign. All right, so looking at the line above, it really does help to write the rest of these problems. Okay, let's look at another one. I give you that angle 3 is congruent to angle 7. So angle 3 and angle 7, that's a given. All right, next one, I say angle 1 is congruent to angle 3. So I'm going to look at my picture first. I always look back at my picture first before I start, struggling on this one. So angle 1 and angle 3. Well, if I notice angle 1 and angle 3, those are vertical angles. So this is the vertical angles congruence theorem. Okay. Now we have angle 7 is congruent to angle 1. Well, let's look at the two statements above it. I have the very first statement is angle 3 is congruent to angle 7, and angle 1 is congruent to angle 3. Well, both of these statements have a 3, so we can cancel those out using our transitive, and we end up with angle 7 is congruent to angle 1, which is our new statement. So this is the transitive property of congruence. Okay, so next up we have angle 7 is congruent to angle 5. Well, let's look back at the picture. Let's see if that helps us. 7 and 5, if you notice, we have vertical angles again. So this is our vertical angles congruence theorem. Okay, and then I have angle 1 is congruent to angle 5. Well, let's look at the two statements above it. Well, I notice that these 7s are the same, so we can cancel out, and we're left over with angle 1 is congruent to angle 5. And once again, we've used our transitive property of congruence. Okay, and our very last one is measure of angle 1 is equal to the measure of angle 5. Well, if we look at the statement above, 1 and 5 are in the same place, but the congruency changes to equality. And when we change from congruency to equality, that's our definition of angle congruence. All right, so that one's a little bit longer. I'm going to use vertical angles congruence theorem a couple times. All right, let's go to the next one. First off, angle 3 is congruent to angle 4, so I'm going to say given. The next statement is 1 is congruent to 4. Well, let's look at 1 and 4. Well, 1 and 4, those are vertical angles. So I'm allowed to say vertical angles congruence theorem. Next up, 1 is congruent to 2. Well, if I look up at the picture, 1 and 2 have a right angle on them. So I can use the right angles congruence theorem. All right, next, angle 3 is congruent to angle 2. This one, if we look at the 3 above it, we actually can do transitive with 3 rows. So the first 2 rows, I can cancel out the 4, and then bottom 2, I can cancel out the 1, and I'm left over with angle 3 is congruent to angle 2. So that one's a much larger transitive property. So this is the transitive property of congruence. And the very last one, I noticed 3 and 2 are in the same place, but the congruency goes to equality. And once again, you're going to learn that one, definition of angle congruency. All right, I have one more for you. Okay, this one starts with the measure of angle 1 is equal to the measure of angle 3. That's our given. Our next piece says the measure of EBA, which I'm going to label on here, EBA, which is right here, is equal to the measure of angle 3 plus the measure of angle 2. So this is part plus part equals whole. So this is our angle addition postulate. And you know it's an addition postulate because we have that plus right there. Okay. Now our next one is the measure of angle EBA is equal to the measure of angle 1 plus the measure of angle 2. Well, if we look at the two statements above, okay, we can use these using substitution because EBA and EBA are the same. 2 and 2 are the same, but if you notice, the measure of 3 and the measure of 1 has been substituted in. Because if measure 1 is equal to measure 3, I can substitute in the measure of 1 for the measure of 3. So that one's a little tricky. Substitution is probably the most difficult one to identify. But that is your example of substitution. All right, next up, I say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle DBC. Let's see if this works out for us. So we have 1 and 2 equal DBC. That does work on our picture, so once again, we have the angle addition postulate, okay? Now, what we have next is we're going to look at the top two. And if I know that the measure of angle 1 plus the measure of angle 2 equals EBA, and also the measure of angle 1 plus the measure of angle 2 is equal to DBC, we can take those out, what's the same, and that's going to be transitive. That's your transitive property of equality. Okay, so that one's a little bit trickier. You will get used to seeing the substitution.